Alright, here is the Unit E review. I'm starting with number 10. The directions are to solve by completing the square. The first thing I want to do is I want to isolate these two terms here since we have a 1x squared, so I'm going to subtract 1 from both sides. And I'm going to leave a blank after the 4x, so x squared minus 4x equals negative 1. So what I need in this spot here is something to make that a perfect square. So that is related to the negative 4. If you divide that by 2, you get negative 2. And then if you square the negative 2, that's the number you get for inside. So I need to have a plus 4 here. Well, what I add to one side, I need to add to the other. And the reason we did this is so that we could factor it to x. So what two numbers multiply to be 4 and add to be negative 4? Negative 2 and negative 2. So x minus 2. Quantity squared equals 3. Now the whole purpose of completing the square is so I can solve by square rooting both sides. So I square root both sides. When you square root a quantity squared, you end up with that base there, x minus 2. When you square root a variable, the other side needs to be a plus or minus, so plus or minus square root 3. I'm going to add 2 to both sides, and this one just becomes our answer, 2 plus or minus square root 3, and that's all we can do on this one. Okay, if you need to pause and rewind, go ahead and do that now. Okay, number 11 is solved by any method. So part of choosing a method is knowing which method you do best. I factor. I enjoy factoring, or I do it well. So I'm going to look at the master product. 6 times negative 3 is negative 18. Are there factors of negative 18 that add or subtract to be negative 2? And the answer is no. So we can't use factoring, and if I can't use factoring, I generally go to completing the square. So not completing the square, I generally go to quadratic formula. So the quadratic formula will be on the EOC sheet, so you may look that up if you need it. X equals, just to be completely sure, let's go ahead and define A, B, and C. A is 6, B is negative 2, C is negative 3. Remember, these need to be in standard form with your x squared first and your x second if you're going to do those in order. So x equals the opposite of b, so the opposite of negative 2, plus or minus the square root of negative 2 squared minus 4 times a times c. And the radical goes all the way out, and the divisor goes all the way across the whole thing, all over 2 times 6. Make sure that your radical includes, or your divisor includes that area right there. Some students tend to forget that. So let's go ahead and simplify. 2 plus or minus negative 2 squared is 4. Negative 4 times 6 is negative 24 times negative 3 is positive 72. All over 2 times 6 is 12. So now we have 2 plus or minus the square root of 76 over 12. And now we need to simplify the radical and reduce. 76 is divisible by 4. It's 4 times 19. 4 comes out of the radical as a 2. 2 square root 19 over 12. And now everything can be reduced by 2. So if we divide every term by 2, we're going to reduce it down, and we end up with 1 plus or minus the square root 19 all over 6. So just to be clear on simplifying the radical, remember 76 was 4 times 19, and the square root of 4 is 2. That's how we get that 2 root 19. If you need to pause and rewind, go ahead and do that now. Alright, number 12 asks us to use the quadratic formula, so we are in standard form. A equals 1, B equals negative 2, c equals -3. Again, you'll be given the quadratic formula on the EOC formula sheet. So we have x equals the opposite of b, so the opposite of -2 is 2, plus or minus the square root of -2 squared, minus 4 times 1 times -3. Radical goes all the way to the end, the divisor bar goes all the way over the whole thing, all over 2a, 2 times 1. So we get 2, plus or minus the square root of 4. -4 times 1 is -4, times -3 is positive 12, all over 2. This gives us 2, plus or minus the square root of 16, all over 2. And the square root of 16 can be simplified to 4. 2 plus or minus 4 all over 2. So we have 2 plus 4 is 6 over 2, and -2 over 2, which gives us 3 and -1. Okay, if you need to pause and rewind, go ahead and do that now. Alright, this is 13. We're asked to complete the square. We're fortunate this one is more difficult, but not the most difficult. So what we need to, what's good to recognize is that everything is divisible by 2. I go ahead and factor out a 2, although you could just divide every term by 2, including on the left and right side, and that would be the same. Because eventually because of that 0, I'm going to go ahead and divide both sides by 2. So an equation with the same solution is x squared plus 2x minus 13. Now to complete the square, I need to get these terms by themselves with a blank in there, so I'm going to add 13, and when I rewrite it, I'm going to leave some space. X squared plus 2x equals 13. And then I need a number in this space to make this a perfect square. So that number is, you take the b term and divide by 2 first, and then you square that. So I need to add 1 here, and what I do to one side I have to do to the other. The reason we've done that is now the left side can factor to x plus 1 quantity squared. The right side is 14. And the purpose for completing the square is so that we can square root both sides. The square root of x plus 1 squared is just x plus 1. When you square root a variable, the other side becomes plus or minus, so plus or minus the square root of 14. Subtract 1 from both sides, and x equals -1 plus or minus the square root of 14. Okay, if you need to pause, go ahead and do so now. Alright, on to number 14. We're going to solve by factoring. I prefer to factor when my x squared term is positive, so I'm going to move this to the other side. And let's go ahead and add 3x squared to both sides. I tend to factor by grouping. I can prove every step on that, but if you need to do the slide and divide, you may do that. But I think actually we don't need either method here, because everything is divisible by 3. Should have looked at that ahead of time, huh? So I'm going to factor out a 3, that's dividing everything by 3. So once we've factored out a 3, all we need to do is, or the next thing to do is to factor this inside. So we're going to say what two numbers multiply to be 9 but add to be 6. And since they're the same, we wonder if it is a perfect square trinomial, and it is. So I'm going to leave that 3, although the 3 outside, although I could have divided both sides by 3. But this factors to x plus 3 quantity squared. And then we set each factor equal to 0. The constant 3 will not be 0, but x plus 3 can be 0. X plus 3 is 0 when subtract 3 from both sides, x is -3. And if you need to put double root for this, since There are two answers, they just both happen to be -3. It is a double root. If you need to pause, go ahead and do so now. Okay, let's look at 15. This is solved by any method. Factoring is the easiest method for me, so I'll look to factor if I can. So I'm going to find my master product, 3 times -2. Are there two numbers that multiply to be -6 but add to be -5? There are, -6 plus 1. So I'm going to go ahead and factor on this. You could do slide and divide. I'm going to use factor by grouping. So I'm going to start by rewriting that -5x to be -6x plus x minus 2. In my first group, I'm going to factor out a 3x. That leaves me with x minus 2. In my second group, there is no common factor, so I'm going to write down a 1 to keep track and have x minus 2. And now I have a common parentheses, x minus 2 and x minus 2, so I write that down. And I have my leftovers, my things in front, the 3x and the plus 1, so I'm going to make that my second parentheses. And this all equals 0. Sorry, I hadn't failed to do that so far. So now I'm going to set each factor equal to 0, so either x minus 2 equals 0, or 3x plus 1 equals 0, and then I solve each. So undo subtraction on the variable with addition, and there's one answer. And 3x equals -1, divide by 3 in that second equation, and we get x equals -1/3. So x is 2 or x is -1/3. You might put it in a solution set form if you want. Go ahead and pause now if you need to. So how do we find the length of one side of this square given this perimeter? How do you know this works? So in terms of factoring, you could say factor out of 4. And use the variable factor and use the variable factor. Or you could just divide the perimeter by 4. And my handwriting's terrible, sorry. Awful. You could also just divide the perimeter by 4. How do we know this works? Because 4 times one side is the perimeter. Four times one side is the perimeter. If you can read those hieroglyphics, good for you. Alright. What is the length of one side? So 16x plus 40 is the same as 4 times 4x plus 10. So this is the letter S for side equals 4x plus 10. Find the simplified expression for the area. So area is side times side, or side squared. 4x plus 10 squared is for a square. So square the first, 16x squared. 2 times the first times the second, and square the second. And there's your expression for the area. Go ahead and pause now if you need to. Okay, I'm on to 17. The length of the dining room is 3x plus 2, and the width is 3x minus 2. Write the simplified expression for the area. I'm going to run out of time here, so hopefully we'll get through this. So we're going to go quick. This is 9x squared minus 4. If you FOIL it out, the inside terms go to 0. And then to solve it, I'm going to say 9x squared minus 4 equals 221. I'm going to solve by square rooting. So I'm going to add 4 to both sides.